Okay, today we're talking about polar coordinates. And if you hear anything in the background, it's my kids watching Tangled, and my kids love Tangled. So it's the sound of the movie and their sounds of absolute glee as they're watching that movie. So if any of you guys have watched that movie, you might be able to relate. But we're talking about polar coordinates today. And so far, all of the coordinates that we've plotted have been rectangular coordinates. So a rectangular coordinate is an x and y value. And what that does is it describes a point in terms of its distance from the origin. So for example, had our point been something like 3, 2, we say its horizontal distance from the origin is 3, right? We have a horizontal distance of 3 and a vertical distance of 2. So we would describe this point in terms of those guidelines, right? We'd say it has a horizontal distance of 3 and a vertical distance of 2. That's a rectangular coordinate, and geometrically you can kind of see why. The polar coordinate system actually describes a point a bit differently. It doesn't describe it in terms of its horizontal and vertical distance, but actually in terms of its directed distance from what we call the pole or the origin, and its angle from what we call the polar axis. So let's break that down. So if we were to have the pole, which is the center of our polar coordinate system, or the pole, or we can call this our origin. It's another way of describing it. We have our polar axis here. And we have our r value, which is our directed distance. And this point over here, which I'll just highlight in blue, this point right here, this is our point P. And that point P, instead of describing it in terms of its x and y values, we describe it in terms of its r, which is, again, its directed distance, and its angle theta, which is this angle here. So our point P, instead of describing it in terms of its horizontal and vertical values, we're describing it in terms of its angle from the polar axis and its directed distance from the pole. So we're going to go ahead and practice plotting a couple of points on our polar coordinate system. But before we do, a couple of quick tips to help you guys out. First off, I always recommend starting with the angle first. So find the angle first. Right? And the second thing is to note that if you end up with an r value that is negative, you're going to want to reflect that r value over the pole. So I'll write that. If r is negative, reflect over the pole. Fix that there. Okay. So let's practice doing that with a couple of values here. So first off, let's start with our p-value. And quick note before we start this, if you haven't already printed out your notes, I strongly recommend actually doing this on your printed out notes instead of just on a piece of binder paper, because it's just going to make it so much more visually appealing and easier for you to navigate. So if I start with my first p-value, and let's just do this one in blue. I always recommend, again, starting with the angle first, pi over 3. Now, let's take a moment to break down what our polar coordinate system looks like here. You'll notice that we have a number of angles, and we are starting at our polar axis, which is right over here, our polar axis. And we start with our polar axis, and we move along in the same direction that we would move along our unit circle. We also have our pole, which is right here in the center. Here's our pole, all right, or also our origin. And something that you probably want to do is label your polar axis. We see a bunch of rings here, and that just represents our distance from our pole. So we're going to make every 2 rings a unit of 1. Okay. And if we were to go back now and plot point P, we'll start with our angle first, which is right over here at pi over 3. So we know that our point is going to be somewhere along this diagonal looking line, if you will, because it has an angle of pi over 3. We would then find the distance of 2 away from the pole, which would mean that our point P has to be right over here. There's our point P. All right, let's try another point. Let's try Q. So Q has an angle of negative pi over 3. And ask yourself, where is negative pi over 3? Well, we know that negative pi over 3 is coterminal with 5 pi over 3. We're going to move clockwise. Negative pi over 3 would be down here. So at 5 pi over 3, now we're going to find a directed distance of 3, which is then right over there. So there's our point Q. So we've got an angle of negative pi over 3 and a distance from the pole of 3. Let's switch on to a different color. Now let's try R. And R is our first instance of an R value that is negative. So again, we're going to go to pi over 3, which is this spot right over here. So pi over 3. And we are going to find a value of negative 2, or directed distance of negative 2. Had our R value just been 2, we would have the same point as P that we've already graphed. But because our R value is negative 2, what did I say right above here? If our R value is negative, we're going to reflect it over the pole. So if we reflect it over the pole, we should be right over here. That's where R should be. Okay? Now, I encourage you now to pause the video and try to do points S and T and identify and locate where these points would be. So if you've tried that, you should see that S, we would have negative pi over 3, which is, again, down here, same place, negative pi over 3. But because our R value is negative 3, we're going to reflect it over the pole, and we would find a point right over here. That's where S should be. And then finally, let's go ahead and identify point T. So 4 pi over 3, and then negative 2. Had it been just 2, we'd be in the same spot as R, but because we have negative 2 and we reflect it over the pole, turns out we're in the same exact spot as P. So both P and T are in the same spot. And in the next section, we'll talk specifically about how to represent the same polar coordinate in a number of different ways.